So we're going to review linear inequalities. And I want to begin with talking about what each one means. And also, there's something I need to stress before we start is, math is a language in and of itself. And what we do in algebra is sort of the very first um, serious course, right? Upper level course that is translating English or whatever your native language is into math language, right? So let's review a little bit before we start doing examples on how to solve linear inequalities. But let's start with the inequalities themselves. All right, so we have, to begin with, we have less than. And basically it reads from left to right like we do in English and Spanish and most languages. Whatever number it may be is less than another number on this side. And here, when you have a line underneath, that means whatever this is, whatever number we're dealing with, less than or equal to a number on this right side. Again, from left to right. Less than, the pointy side facing the left. Then we have the greater than. Greater than, whatever number is here, greater than or equal to. Do you notice the line? That gives us the or equal to. Greater than or equal to the number on the right side. And here, the wide side, right? Whatever number is here is greater than, there's no line, so it's just greater than the number on the right. And that's how we read it. It's basically a short form of writing your native language. And it's an easy way to read things and to calculate things. So let's look at some examples. How would we read this? 4 is less than 24. Simple. Negative 4 is less than 24. Or negative 4 is less than or equal to negative 4. It means it could be smaller than or equal to negative 4. And it is. Here in green, 71 is larger, greater than 9. That's a true statement. Negative 71 is greater than negative 100. Now the negatives give a challenge. I like to always think of them as having money or owing money. Positive meaning having, negative meaning owing, because it kind of makes things real. If I owe $71, that's greater, or it means I have less of a debt, right? I could have, essentially, I have more money because I have less debt than if I owe $100. So negative 71 is greater than negative 100. I would prefer to have this debt, right? It has more value having this debt than having this debt, negative 100. So negative 71 is greater than or equal to negative 71. Make sense? So keep in mind that inequalities, we read them from left to right. And you just have to be careful with them. We follow the same rules when we solve inequalities, except whenever we multiply or divide by a negative number, okay, we have to flip the inequality. So let's work on this. And I'm going to use a pencil first, just for fun's sake. I want to get my x alone. Here's my x. Okay, I want to get that alone. That means that 2, I want to move to the other side. And how I do it is I subtract 2 from both sides. 2 minus 2 will give me x plus 0 is greater than 4 minus 2, which is 2. X plus 0 is x is greater than 2. So how do I answer this? Well, I do not have a line underneath, so I do an open circle at this number 2, and I say to myself, whatever number this is, it has to be larger than 2. Where is it larger than 2? Where is it greater than 2? All of these numbers here. And so I highlight that, all of those numbers here. And that's how I solve that. Okay, that shows any of these numbers, if I were to replace it where the x is, gives true. 8 is larger than 2. 6 is greater than 2. All of these work up until positive infinity. Yeah, that's sideways 8. Positive infinity. It goes on forever. All those numbers will give me a true statement. Whatever number, positive 4,000 is greater than 2. They all work. Let's do another example here now. I'm going to move this over. A little more complicated, right? This is a 2-step inequality. All right, the first thing we're going to do is we need to figure out, I want to get this x alone. Okay, I have to move whatever is plus or minus to the x. I am going to move the positive 4. How do I do that? Well, I say minus 4 minus 4. 4 minus 4, 0 plus negative 2x. I still want my x alone. is greater than or equal to 4. Negative 2x is greater than or equal to 4. Okay, let me make this a little bit darker. Negative 2x greater than or equal to 4. Here, I need to get that x alone. It's negative 2 times x. So I'm going to divide both sides by negative 2. When I multiply or divide both sides by a negative number, I must flip the inequality. I'm going to finish this over here. So negative 2 divided by negative 2 gives me 1 times x is less than or equal to, because I divided both by negative 2. That works for division on both sides of negative number or multiplication on both sides. In this case, it was division. 4 divided by negative 2, negative 2. X is, did we flip it? Yes, we did. Less than or equal to negative 2. So now I go here. This means whatever number is going to work has to be smaller than or equal to negative 2. So here's my negative 2. Because there's an equal sign, it is filled. That means it includes that number. If there's no equal sign, it doesn't include negative 2. This says whatever number's here has to be smaller than or equal to negative 2. And how do we show equal to? We fill in the dot. Where are my smaller numbers to negative 2? In this direction. And, many of you did this in pre-algebra, and that's okay. Any number here gives me a true statement. Negative 10 is less than or equal to negative 2. Negative 400 is less than or equal to negative 2. They all work. Now, let's go to this one here. This one is a little bit larger, or a few more steps. How do we attack this problem? Okay, so the first thing you have to realize is you have a variable, and it's inside the parentheses, right? So we need to free it up because I want to get it alone. I have to solve and see what x is greater than or equal to a certain number. So in order to get that r and to free it, I have to distribute. There's no other choice here. If it was outside here, maybe I wouldn't have to do that. But it's in there. I got to set it free. And how do I set it free? I'm going to have to use distributive property. 6 times 1, 6. 6 times negative 5, negative 30r. Minus 4 is less than 152. Okay, I have a 6 and I have a minus 4. That gives me 2 minus 30r is less than 152. See how that's looking a little better? I need to get my r alone. Let me underline that. R. It looks like OR, right? I need to get that r alone. And I'm going to do it. Got to move whatever's plus or minus to the r. It's positive 2. I subtract 2 on both sides. One time. 2 take away 2 is 0 minus 30. R is less than 150. 0 minus 30r is negative 30r, less than 150. And my final thing is I have to get rid of that negative 30 times r. How do I do that? I divide by negative 30 both sides. And when that happens, negative 30 divided by negative 30 is 1 times r. Flip it because I divided by both sides, negative 30. 150 divided by negative 30 is negative 5. If you want to think of it, you can cancel out those two zeros. 15 divided by 3 is 5. One's positive, one's negative, negative 5. R, make sure I flipped it, greater than negative 5. And how do we do? We find negative 5. There was no equal sign, right? So it is an open circle. It does not include negative 5 in the solution. Whatever number this is has to be larger than negative 5. And that means all my numbers larger than negative 5 go in this direction. And there's my answer. So this is how we figure this out. Okay? Now, let me pause that for a second, and we're going to do one final one. Now, this is a little bit longer. You may say, oh my goodness, this is too long. But this is good because it's good practice. Similar to the equations, this is just inequalities. The only difference is, once again, we have to make sure that if we multiply or divide at the end or sometime in the inequality to get the variable alone, when we multiply by a negative number or divide, we have to flip the inequality. Important rule. You can't forget it. Okay. All right. I have a variable. I have a variable. I have a variable. I got to get all my variables alone. And they're inside these parentheses. So I will have to distribute. Okay? Negative 2 times r. Negative 2r. Negative 2 times 2, negative 4. Less than or equal to 6r. 11 times r plus r. 11 times 10, 110. Starting to see that? Okay. Can anything on this side go together? Are there like terms? No. I'm going to write this in blue now because I think you can see it a little better. Negative 2r minus 4, less than or equal to. Do I have like terms over here? I have an r. Oh, I have another r. 6 plus 11 is 17r plus 110. Starting to look a lot easier, right? We have to get our r's on the same side. Okay? All right, so let's do that. I'm going to move my r. Even though this is a larger number, 17 is larger than negative 2, I'm moving it over here because of that inequality. And sometimes it's hard to read. So I'm going to subtract negative 17r, negative 17r. This becomes 0 plus 110. Negative 2 minus 17. I owe $2. I owe 17. Guess what? I owe 19r minus 4. I'm going to add 4 to both sides. Negative 19r plus 0 less than, I haven't flipped anything because I haven't multiplied or divided anything. 0 plus 110 plus 4 is 114. Negative 19r less than or equal to 114. Okay, now we're going to have to divide both sides by negative 19. Negative 19. Okay, when I do that, this gives me 1 times r. Flip. That should be negative 19. A negative 114 divided by 19. Okay, so let's figure this out. Let's say we didn't have a calculator with us. Well, we're going to have to figure it out. 19 divided by 114. 114 divided by 19, rather. Okay, let's give it a shot. 19 times, I don't know, 5. Let's try. 45. 5 plus 4 is 95. Almost. We'll have to try 19 times 6. 54. What is that? 114. Hey, we did it. Pretty simple, right? If you're stuck without a calculator, you can find the answer. It just may take a few tries. So this is negative 6. R is greater than or equal to negative 6. I come here. I go to negative 6. Because of this line underneath, it means it includes whatever number I put here has to be larger than or equal to negative 6. And my larger numbers are in this direction to positive infinity. Okay, all the way that way. Any of those numbers gives this a true statement. And if I plug them in here, it will give me a true statement at the end. And that's how we do inequalities. So I hope that helped. Good luck with your practice. And hope you understood it. You can always watch this again.